Here we have a little breadboard mock-up of subcircuits 1, 2, 3, 6, and 7 from the previous post. And just to introduce, yes, it's a lot of capacitors, but it works. This fan represents the UV bulbs. This LED right here represents the LED voltmeter. That LED represents the pump. The last LED in the back is this little status light. And what this should do is, what this consists of is, it has a voltage regulator circuit, which will only turn on the UV bulbs if there's enough power to make 12 volts. We have the LED voltmeter, however, will run off of less than 12, but when 12 becomes available, power switches so it runs only on 12 volts. That way we don't risk overvolting it. Here is the pump timer that delays the pump startup. It's set to around 20 seconds, but we can change that with the potentiometer right there. So let's test it all out. First I'll be plugging in this little power brick, and this is 6 volts. So notice that only the LED voltmeter light turns on, so only the LED voltmeter is on. There's not enough voltage to run the fans, or the bulbs, so the bulbs are switched off. This is a 12 volt power brick, so now we have combined 18 volts. Okay. And notice that the fan turns on. Everything's on, and this light should turn on after 20 seconds. Okay, any second now? There we go, it's on. It's fairly dim, but there it is, it's on. So that's the pump. And just to prove what's going on here, right? If I take the supply voltage, we have 20. And the voltage going to the fan is 11.9. So that proves that it's running off of regulated power. And here's our pump. And if I were to, if a fault were to happen in the bulbs, I would trip this line, and there we go. Red, not green. That indicates a bulb fault.